Factoring is a very important skill when you work with algebraic expressions. We use factoring when we find least common denominators, when we add and subtract algebraic fractions. We use factoring sometimes to simplify algebraic expressions, and sometimes we need to use factoring to solve equations. At this point, you have learned several factoring techniques and have practiced those techniques. In this lesson, we would like to show you some problems that are all mixed together and talk about a strategy when you know you need to factor. What kind of steps or questions would you ask yourself to work that factoring problem? Let's take a look at the steps that we would consider. The first step is to always ask yourself, is there a greatest common factor? It is very important that if there is one, you factor this out. The reason for getting that greatest common factor out first is because that will reduce the size of the numbers in the rest of the problem if you do have a common factor. Also, getting that common factor out at the beginning will be sure that you do not inadvertently leave factors that are not completely factored later on. So for every factoring problem, always very first ask yourself if there is a greatest common factor. The second thing you would consider is how many terms are there in this polynomial. If there are two terms, which is what we call a binomial, you should ask yourself if it is a difference of squares. You have learned how to factor difference of squares, and so if you recognize that, you will be able to get the factors. If it's not difference of squares, ask yourself if it is sum of squares. You should recall that a sum of squares will not factor, and so you can with confidence know that that would be a prime factor. If it is not a sum or difference of squares, perhaps it would be a sum or difference of cubes. We have also had formulas that would tell us how to factor sum or difference of cubes. If you do not have two terms, perhaps you have three, a trinomial. The first thing you should check for on a trinomial is to see if this might be a perfect square trinomial. The reason we want to check this first is because it is very easy to check for, and if it is a perfect square trinomial, then we will have the factors. If it is not a perfect square trinomial, then we can very quickly rule that out and go on to step number 2, which is to try our guess and check with FOIL. If you do not have 2 or 3 terms, but you have 4 or more terms, you want to ask yourself, will grouping work? Sometimes you will group two terms together, or perhaps sometimes you may group 3 terms together. But this again is a trial and error process to see if grouping works. Always for the last step, check your factors. Can any factor be factored further? You want to look at that to make sure that you did not inadvertently leave out a greatest common factor in the very beginning. Having looked at these steps, we're going to look at a series of problems. These problems are all mixed together. What I'm going to do is show you the problem, and if you would like to, you might want to pause your tape and try working the problem on your own before I work it for you. So I will wait a few minutes for that. If you choose not to work it on your own, you may simply just leave the tape running and I will work the problem for you. 5x cubed minus 80xy squared. If we need to factor this, the first thing we will do, remember, is to look for a greatest common factor. Looking at my numbers, it is easily seen that 5 is a common factor of both 5 and 80. So I know I can factor out the number 5. But looking at my letters, I notice that I do have x's in both terms as well, the smallest exponent being x to the first power. So I also have a common factor of x. factoring out the common factor of 5x, we will have x squared minus 16y squared. Now, having factored out the greatest common factor, we're going to look at this factor that remains. It is a binomial with two terms. That first question we wanted to ask is this difference of squares? And of course, you can see that it is a difference of two perfect squares. So we know that to factor this, we will simply get conjugates of the square roots of these two terms. Let's bring down our common factor of 5x. The square roots will be x and 4y. Conjugates, remember, are binomials that look alike except for the sign in between the two terms. X plus 4y, x minus 4y are the factors of x squared minus 16y squared. Our complete factorization then are the three factors 5x times x plus 4y times x minus 4y. You can see that none of these factors can be factored any further. Two x squared plus 12x plus 18. Again, the first thing that I will look for is a greatest common factor. Looking at these numbers, I see that 2 is a common factor of all three of those terms. We do not have any variables that are common factors for all three terms. Factoring out 2, we have x squared plus 6x plus 9. Now, looking at this trinomial, the first thing to consider is, could this be a perfect square trinomial? I notice that my first term is a perfect square, which is required. My third term is also a perfect square, and it has a plus sign in front of it, which is also required in a perfect square trinomial. Let's check to see if this is a perfect square trinomial. The square root of the first term is x. The square root of the third term is 3. If I multiply 3 times x and double that answer, I get 6x, which is my middle term here. So this is a perfect square trinomial. Recall that the sign of this middle term is the sign that would go in between these two terms in my factor. So bringing down my common factor of 2, the complete factorization will be 2 times the quantity x plus 3 squared. $250x cubed minus 54y cubed. Looking for a greatest common factor, I notice that both 250 and 54 are divisible by 2. So I will factor out the common factor of 2. That will give me 125x cubed minus 27y cubed. Looking at the binomial factor that I have here, I notice it is not a difference of squares because my variables are to the third power. It is also, of course, not a sum of squares. Could this be a difference of cubes? Is 125 some number cubed? Yes, it is. It's 5 cubed. So my first term is 5x cubed. My second term is also a perfect cube. The cube root of 27 is 3. So this second term is 3y cubed. Recognizing that I do have a difference of cubes, I will use my formula for factoring the difference of two cubes. let's bring down this common factor of 2 before we forget to do that. When we factor difference of cubes, our first factor contains the cube roots of these terms here. So I will write 5x and 3y. The sign of this first factor is always the same as the sign in this original problem. So I know this first factor is 5x minus 3y. For the second factor, I look at the term that I wrote here and I square this term. So squaring 5x, I get 25x squared. The sign that goes here is always the opposite of the sign that is in this first factor, so I know this will be a plus sign. This middle term in the second factor is the product of these two terms here, ignoring the sign. So 3y times 5x gives me 15xy. And then to get the third term of this second factor, I square my second term in my first factor. Squaring 3y, I have a plus 9y squared. So my complete factorization here is 2 times 5x minus 3y times 25x squared plus 15xy plus 9y squared. (24x y squared) plus 36xy plus 8y squared plus 12y. Is there a common factor? Looking at all of these numbers, 24, 36, 8, and 12, I notice that I can divide all of these numbers by 4. So I know that 4 is a common factor here. Looking at the variables, I notice that I do have the variable y in every one of these terms. And so the smallest exponent that y appears is to the first power. So I can also factor out y. Let's factor out 4y. That will leave me a 6xy plus 9x plus 2y plus 3. Now let's just double check to make sure we factor correctly. We can multiply quickly. This is 24xy squared plus 36xy plus 8y squared plus 12y. We know that we do have the correct factorization then at this point. Now, this has more than 3 terms. So we know that to factor this, if we can factor it anymore, will require grouping. So since I'm going to be doing some grouping, let's rewrite this. Let's bring down the 4y, and I'm going to use a bracket. Since all of these signs are plus signs, I can group the first 2 terms, 6xy plus 9x, and then the second 2 terms, 2y plus 3, and then use my bracket to close that off. Recall with grouping, you're going to look within each of these groups then to see if you have a common factor that can be factored out of that group. Don't forget to continue bringing down this common factor 4y. Looking at these 2 terms, I can factor out a 3x. Factoring out 3x gives me 2y plus 3. And then in this second group, I do not have a common factor, so I will simply recopy the 2y plus 3. Notice that this factor of 2y plus 3 is the same. And also recall that in front of this parenthesis, a 1 is understood to be there. Since we have a common factor of 2y plus 3, we will factor that out. Bring down your 4y that you already have. You are factoring out 2y plus 3, and when you factor out the 2y plus 3, it's going to leave 3x plus 1. in the second factor. So our three factors are 4y times 2y plus 3 times 3x plus 1. If you feel a little bit unsure of yourself with these problems that require grouping, remember that you can check your solution by doing FOIL on these factors. Let's just do a quick check here to show you how to do that. Bring down this common factor of 4y. Using FOIL, 2y times 3x is 6xy. The outside product is a plus 2y. The inside product is a plus 9x. And the last two terms multiplied together is a plus 3. Let's compare this to what we had up here where we had checked previously. I have the 6xy, I have the 9x, I have the 2y, and I have the 3. So this problem, though it's in a different order, is the same as this problem. So we can be sure at this point that this is correct. You could, of course, distribute your 4y and see that you have the original problem. X to the fourth minus 1. This problem does not have a common factor. So we will go to the second step and notice that this is a binomial. It has two terms. My first question then is, could this be a difference of squares? And as you see, yes it is. X to the fourth is x squared squared, and 1 is 1 squared. Since we have a difference of squares, we know that the factors are the conjugates using the square roots of these terms. The square roots are x squared and 1. Conjugates means that in one factor we will use a plus sign, and in the other factor we will use a minus sign. So we have x squared plus 1 times x squared minus 1. Now, don't forget about that very last step that we discussed earlier. Can either of these factors be factored some more? Looking at this first factor, I notice this is a sum of two squares. We cannot factor a sum of two squares, so this factor cannot be factored anymore. This factor, however, is another difference of two squares, so this one we can factor some more. Since we can factor this second one, we're simply going to bring down this first factor of x squared plus 1, and then we will factor this difference of squares using the conjugates of the square roots, x plus 1, x minus 1. This problem then had three factors, x squared plus 1, x plus 1, and x minus 1. Four x squared plus 20x plus 25. Looking at this problem, I do not have a common factor. So I will move down, counting terms. There are three terms. This is a trinomial. The first thing I should check for is to see if this is a perfect square trinomial. My first term is a perfect square. My third term is a perfect square, and I do have a plus sign here. So if this middle term works out, we will have a perfect square trinomial. The square root of my first term is 2x. The square root of my third term is 5. If I multiply these two together, I get 10x. If I double 10x, I do have 20x, which is the middle term up here. So this is a perfect square trinomial. Since my middle term up here is positive, I will have a plus sign between these two terms, and this will be 2x plus 5 quantity squared. 15xz minus 9x minus 10yz plus 6y. Looking at this polynomial, I do not see a greatest common factor. Since there are 4 terms, I know that I will need to try grouping to work this problem. Recall that when you set up your groups, you want to be very careful that when you insert parentheses, you do not change the problem as it's written. If I choose to group the first 2 terms and the second 2 terms, because of this minus sign right here, I want to be very careful. So I'm going to first of all rewrite this problem. 15xz minus 9x, and instead of writing minus 10yz, I'm going to write that as plus a negative 10yz plus 6y. Notice that plus a negative is just another way of writing minus. So I have not changed this problem. That allows me, however, to insert parentheses around this plus sign. And if you check at this point, if you were to remove your parentheses, you would have 15xz minus 9x. This would give you your minus 10yz, and you would still have a plus 6y. So our problem is correctly grouped. In this first grouping, I have a common factor of 3x. Factoring out 3x, I get 5z minus 3. Now sometimes I kind of plan ahead. Noticing that I had 5z minus 3 will help me when I look at these factors to decide if I want to factor out a positive number or a negative number. Now looking at these, I know that I can factor out 2y. If I do this as a positive 2y, this term will be negative 5z, which will not be the same sign as this one. So I'm going to choose to factor out negative 2y. Factoring negative 2y out of negative 10yz gives me a positive 5z. And factoring a negative 2y out of positive 6y gives me a negative 3. Check this. Multiplying here we have a negative 10yz, and multiplying here we have a positive 6y. That has given me the same factor of 5z minus 3. So I'm going to bring that factor out, 5z minus 3, and when I factor that out, it leaves 3x and minus 2y. So my correct factors are 5z minus 3 times 3x minus 2y. I just noticed that this problem has an error. There's not supposed to be an exponent on that 27, so let me just kind of mark that out for a minute. This problem should read 8x cubed minus 27. There is not a common factor for this problem. So we will move to the second step and notice that this is a binomial. It is not a difference of squares, obviously. Could it be a difference of cubes? 8x cubed is a perfect cube. Its cube root is 2x. And the cube root of 27 is 3. So this is a difference of cubes. To factor this, we will take the cube roots of 2x and 3. Our sign here will agree with the sign in the problem, so I will have 2x minus 3 here. For my second factor, I will square this first term right here. If I square 2x, I have 4x squared. And then remember, this sign is always the opposite of the sign in my first factor. Multiplying these two terms together and ignoring the sign, 3 times 2x gives me a 6x for this middle term here. And then if I square 3, I get a plus 9. My factors are 2x minus 3 and 4x squared plus 6x plus 9. Now you might be looking at this second factor here and thinking perhaps it is a perfect square trinomial. The first term certainly is a perfect square, and so is the last term, and we do have our plus sign. But I would like for you to notice the square root of this first term is 2x. The square root of this last term is 3. If I multiply these, I get 6x. But then remember, you have to double that for a perfect square trinomial. If I double 6x, this term would have to be 12x. So since I do not have the correct middle term, I cannot factor that second factor anymore. This would be the correct factorization as we have it written here. Nine subtract 49x squared. There is not a common factor in this problem. It is a binomial. The first question, could this be difference of squares? 9 is a perfect square, and 49x squared also is a perfect square. So this will factor into the conjugates of the square roots of these two terms. The square roots will be 3 and 7x. So one factor will have 3 plus 7x, and the second factor will have 3 subtract 7x. Five x squared plus 80xy plus 300y squared. Is there a common factor in this problem? All of these numbers can be divided by 5, so we do have a common factor. There are no variable common factors. Factoring out 5, we have x squared plus 16xy plus 60y squared. Looking at my trinomial that I have here, could this be a perfect square trinomial? You'll notice the first term is okay, but look at your third term. 60 is not a perfect square, so we know right away that this is not a perfect square trinomial. So that tells me that I will need to just try guess and check using FOIL. Let's bring down this common factor of 5 and make some empty parentheses here. The only way to have x squared is to use the factors x times x. Since my third term is positive, I will have same signs. Both of those signs will be positive since my middle term is positive, so we may write those signs in. We need to use factors of 60y squared in these two positions. To get 60y squared, we could of course have 1y times 60y. We could have 2y times 30y. We could have 3y times 20y. Let's see, will 4 go into 60? I believe it will. 4y times 15y. 5 will go into 60. 5y times 12y. 6y times 10y. I believe that's all the different choices that we have. We had lots of them. We want to, out of these choices, find the one that will give us 16xy for our middle term. Recall that that middle term is the result of adding our outside and inside products. So we need factors that will add to 16. Let's try 6y and 10y here. Checking this, we have x squared. Our outside product is a plus 10y. Our inside product is a plus 6. xy. This is a 6xy here. Adding those, we get 16xy for the middle term, and then multiplying here, we have 60y squared. So our factors are 5 times x plus 6y times x plus 10y. You'll notice that none of these can be factored anymore. (25x squared minus 16). I do not see a common factor here. Could this be a difference of squares? I believe it is. 25x squared is a perfect square, and so is 16. The square roots are 5x and 4, so we will get conjugates using the 5x and the 4. The factors are 5x plus 4 times 5x minus 4. These cannot be factored any further. (9x squared minus 42x plus 49). I do not see a common factor in this trinomial. Since this is a trinomial, we will check to see if it is a perfect square trinomial. Our first term is certainly a perfect square. Our last term is a perfect square, and we do have the plus sign in front of it, which is necessary. Let's check to see if this will work for that middle term. The square root of 9x squared is 3x. The square root of 49 is 7. If I multiply these, 3x times 7 is 21x. If I double 21x, I do get 42x. This is a perfect square trinomial. Since my middle term is negative, I will have a minus sign between these two terms, and the correct factorization will be 3x minus 7 quantity squared. X cubed plus 64. There is not a common factor in this problem. It is obviously not a difference of squares or a sum of squares, but notice that it is a sum of two perfect cubes. 64 is 4 cubed. Since it is a sum of cubes, we will take the cube roots, x and 4. Since our problem has a plus sign, we will put a plus sign in this first factor. What I have written here, I will square, so I will get x squared here. This sign will be a negative to be the opposite of this one. Then ignoring the sign, x times 4 is 4x, and squaring 4, I get a plus 16. My factors are x plus 4 times x squared minus 4x plus 16. You can check again, like we did earlier, this is not a perfect square trinomial because the middle term will not be twice the product of the square roots of this first and last term. So we cannot factor this anymore. (24x squared minus 37x minus 5). I do not see a common factor in this problem. I have 3 terms. Could it be a perfect square trinomial? We can rule that out right away because of this 24 not being a perfect square. So we know that the method to use here is to guess and check. Let's make some parentheses, and we're going to have several choices. For 24x squared, I could have 1x times 24x. I could have 2x times 12x, 3x times 8x, 4x times 6x. So there are 4 choices here. Since I have so many choices, I might want to go ahead and look at my third term. The numbers that go in this last position have to be factors of 5. Since there's only one choice for factors of 5, I'm going to go ahead and put in 1 and 5 here because I know those have to be the numbers. Notice this third term is negative, so I will have opposite signs in these factors. What we want to try to do here is to think about this outside and inside product using these choices to see if with opposite signs we can come up with a negative 37x. Well, let's see what we might try. I think we might need to use some fairly large numbers perhaps. Remember that what we place here is going to be multiplied by 5. We want to try to get something in the vicinity of 37. I think I'm going to try this 3x and 8x right here. My thinking is if I put 8x right here, this outside product is a 40x, which is fairly close to 37. And you'll notice this other factor then would have to be a 3x right here. This inside product is 3x. The difference between 40x and 3x is 37x. Now let's trace that sign. We want to have a negative 37. That would require negative 40x and a plus 3x here. So following that sign, I would need the negative in this factor and the positive here. Now let's double check to make sure that we do have the correct factors. 8x times 3x is 24x squared. My outside product is negative 40x. My inside product is positive 3x, which adds up to negative 37x. And my last two terms multiplied together give me negative 5. These are the correct factors. 8x plus 1 times 3x minus 5. $50x squared plus 18. There is a common factor in this problem. Both of these numbers can be divided by 2. So we have a common factor of 2 here. Factoring that out, I have 25x squared plus 9. You can check to see that that is correct. Can we factor this anymore? This is a binomial. If you notice, however, it is a sum of 2 perfect squares. We know that we cannot factor a sum of 2 squares like this when the common factor has already been taken out. So our complete factorization is simply 2 times 25x squared plus 9. X to the 6th minus 64. I wanted to do this problem last because it's a little bit unique in some of its characteristics, and we're going to discuss what we might want to do with this problem. First of all, notice that there is not a greatest common factor for these two terms. Since it is a binomial, I will check first to see if this is a difference of squares. 64, of course, is a perfect square. What about x to the 6th? If you remember your rules for exponents, if I have x cubed squared, I multiply these exponents and get x to the 6th. So x to the 6th is a perfect square. So I'm going to write this as x cubed squared minus 8 squared so that we can see this difference of squares. If we have difference of squares, our factors are conjugates using the square roots. So my factors would be x cubed plus 8 and x cubed minus 8. You can see if we multiply this, we would have x to the 6th minus 64. Did you notice that each of these factors that we've written down, however, can be factored some more? X cubed plus 8 is a sum of two perfect cubes. So using our rule for factoring perfect cubes like this, the cube roots are x and 2. I will have a plus sign since my problem here has a plus sign. And then squaring this first term, I get x squared. The opposite sign would be negative. X times 2 is 2x, and square 2 to get 4. Then on my difference of cubes, I will use the cube roots x and 2, but this time I will have a negative between them. And then squaring this one, I have x squared. The opposite sign is plus. X times 2 is 2x, and squaring 2, I get 4. I have 4 factors for x to the 6th minus 64. Now, you may be saying to yourself, I didn't notice that it was a difference of squares, but I thought it might be a difference of cubes. Let's take a look at that. Could this be a difference of cubes? If I have x squared cubed, that's x to the 6th, and 64 is 4 cubed. Sure enough, it is a difference of cubes. Let's factor this using our rule for difference of cubes, and then we're going to compare our answers. Using my difference of cubes rule, I will take the cube roots, which are x squared and 4, and I will use the minus sign between them. Then, looking here, I will square this and get x to the 4th. My opposite sign is a plus, 4 times x squared, and then if I square this, I get a plus 16. Now, I recognize this is difference of squares, so I will factor into x plus 2 times x minus 2. And I don't know how to factor this. It is not a perfect square trinomial, as you can check. So I have these factors. Notice here I only have 3 factors. The x plus 2 and x minus 2 factors are the same. But this factor is not the same as these two. Now, let's do this, one quick little check. If I multiply these two factors together, would I get this factor right here? Let's check that. Multiplying each of these terms here by x squared, I will have x to the 4th plus 2x cubed plus 4x squared. And then multiplying everything by the negative 2x, I have a negative 2x cubed, a negative 4x squared, and a negative 8x. Then multiplying each term by 4, I have a plus 4x squared plus 8x plus 16. Let's add like terms. Bring down this x to the 4th. I'm going to check that off that we've done that. 2x cubed minus 2x cubed. Those add to 0. 4x squared minus 4x squared. That adds to 0, but notice I still have this plus 4x squared here. Let's check that off. Minus 8x plus 8x adds to 0. And then I have this plus 16. You can see that the product of these two factors does give us this factor here. Now, faced with this problem then, what should we do? If it is both a difference of squares and a difference of cubes, which is the correct factorization? Well, both are correct factorizations, but only this one is factored completely. Remember, to factor completely, you have to be sure that none of your factors can be factored some more. We have seen that this can be factored into the product of these two factors. So this is not a prime factor. Now, how would we factor x to the 4th plus 4x squared plus 16 to get these two factors? It would be a very difficult process and one that you have not learned to do. So the best guideline that we can give you at this point is, notice in our sequence of steps, we said if it is a binomial, you should look for difference of squares first. If it is a difference of squares, you want to go that direction, because following the difference of squares, then if you're able to factor some more, you will have it factored completely. The difference of cubes gives us a correct factorization, but one that is not factored completely. So we would prefer this solution as the prime factorization of x to the 6th minus 64. I hope that this factoring summary has helped you tie together all of the rules that you learned for factoring in the other sections of your text. I hope that you've seen that as you approach a factoring problem, you can follow certain guidelines that will help you to have the right strategy for finding those factors. We appreciate the time that you've taken to watch this tape. If you would please rewind this tape before you turn it back into the math lab so that the next student will have it ready to go. Thank you very much.